Hello students, in the last video we studied IUPAC nomenclature of organic compound, and today we are going to study the new concept from your syllabus, that is isomerism. Isomerism, it is important for the examination point of view. It is for 2 marks. So let's discuss first of all the definition of isomerism. Okay, so isomerism. Whatever the isomerism word is there, that comes from Greek word. Actually, isomerism, it is obtained from isomer. So isomer is having a two modes. Isomer is having a two part. One is the iso and second one is the mer. What do you mean by iso? Iso is a Greek word and mer also Greek word. Iso means same and mer means part. Same part. And its phenomenon is called isomerism. So let's discuss right now definition of isomerism. When two or more compound having same molecular formula but different physical and chemical properties are called isomer, and its phenomenon is called isomerism. Isomerism, basically they are classified in two types. One is structural isomerism and another stereoisomerism. They are classified in two types. One is structural isomerism. Structural isomerism. And second one, stereoisomerism. Stereoisomerism. And what is this structural isomerism is there? They are also classified in following types. Structural isomerism, they are classified as chain isomerism. Chain isomerism. Second, position or positional isomerism. Position or positional isomerism. Next, functional isomerism. Functional isomerism. Next, metamerism or metamers. Next one is there tautomerism. And stereoisomerism also they are classified in two types. One is there geometrical isomerism. Geometrical isomerism. And second one, optical isomerism. Optical isomerism. So this is the classification of isomerism. So first of all, let's discuss structural isomerism. What do you mean by structural isomerism? Structural isomerism defined as when two or more compounds having same molecular formula but they have different structural formulae are called structural isomerism. In the structural isomerism, two or more compound having same molecular formula but they have different structural formulae. Once if it is having a different structural formulae, they would have different physical and chemical properties are called structural isomerism. And structure and what about stereoisomerism? Stereo word it is mean spatial, in space. What do you mean by stereoisomerism? When two or more compound having same molecular formula but the spatial arrangement of atom or group of atom is different are called stereoisomerism. And stereoisomerism they are classified in two types. One is there geometrical isomerism and optical isomerism. So let's discuss first of all chain isomerism. defined as when two or more compound having same molecular formula. When two or more compound having same molecular formula, but they differ in their structure on the chain, are called chain isomerism. For example, I write the butane. Example, butane, CH3, single bond CH2, single bond CH2 and CH3. This is called N-butane. I write another example, CH3, single bond CH, single bond CH3, and here I write CH3. This is called isobutane. So what is the chain isomerism? Two or more compound. Here you will find same number of carbon atom, same number of hydrogen in both the structure. But what happens? This chain is there. This is continuous chain is there. Here one of the methyl group is removed and is attached somewhere on the chain. So you will get different structural formula, that is called chain isomerism. Means they are differ on the chain. So what do you mean by chain isomerism? When two or more compound having the same molecular formula, but they have different structure on the chain. Structural arrangement is different, are called chain isomerism. Example is N-butane, where all the carbon atoms are bonded in open chain manner, in straight chain manner. But in this case, one of the methyl group, one of the carbon atoms they are removed and they are attached somewhere on the chain. So that's why you will get a different compound, are called isobutane, are called chain isomerism. So next we will discuss positional isomerism or position isomerism. In the positional isomerism or position isomerism, in which when two or more compound having same molecular formula, but they are differ in their position of functional group, are called positional isomerism. I will write the example. Example is CH3, CH2 and CH3OH, sorry, CH2OH, CH2OH. This is one of the example. Second example I will write CH3, CH3. Here I will write the OH. So what is the positional isomerism? When two or more compound having the same molecular formula, but they are differ in the position of functional group. So in this case, OH is the functional group is there. OH is the functional group is there. I will give the number first of all. I will give the number backward direction. 1, 2, 3. 1, 2, 3. So in this example, OH is the functional group. Right? Alcohol is the functional group. But in the first example, OH group as a functional group is attached to the first carbon atom on the chain. Whereas in the second example, OH group as a functional group is attached to the second carbon atom. So first example, the position of the OH group is attached to the first carbon atom, and in the second example, OH as a functional group is attached to the second carbon atom. The position is changed. But if you count the number of hydrogen atom, number of carbon atom and oxygen atom, both example is remain same. It's called positional isomerism. One more example I will write. I write here CH3, CH2, CH2 as a Cl, and CH3, CH3 and Cl. So this is also another example is there, where the position of the Cl group in the first example is attached to the first carbon atom, but in the second example, Cl group is attached to the second carbon atom. This is called positional isomerism. That differ in the position of functional group, are called positional isomerism. So next, what is the name of this one? So it is called propane 1-OL, and it's called isopropyl alcohol or propane 2-OL. This is called 1-chloropropane. It's called 2-chloropropane. Next, we are going to study the functional isomerism. What is the functional isomerism? In the functional isomerism, when two or more compounds having the same molecular formula, but they have different functional group, are called functional isomerism. Example, avoid the example: CH3, CH2, OH. This is called ethyl alcohol. Ethyl alcohol. Its isomer, I will write the functional isomer. I will write CH3, O, CH3. This is called dimethyl ether. Dimethyl ether. So identify the functional group. In the first example, alcoholic group, OH as a functional group is there. Alcoholic group. And second example, ether as a functional group is there. Ether as a functional group is there. But if you count the number of carbon atoms and number of hydrogen atom and oxygen atom, in the both examples are remain same, but they are different in the functional group. That is called functional isomerism. One more example I will write. CH3, C double bond O, CH3. This is called acetone, but its IUPAC name is propane 2-ONE or propanol. Its isomer I will write CH3, CH2, and I will write as a CH4. See, here also 3 carbon atom is there, there also 3 carbon atom is there. If you count the number of hydrogen, in this example 6 hydrogen atoms are there, here also 6 hydrogen atoms are there, 1 oxygen is there, here also 1 oxygen is there, but they are differ in their functional group. So in the first example, we will find ketonic as functional group, ketone group is there, and in the second example, we will find aldehyde group. Which group? Aldehyde group. So this is called acetone or propane 2-ONE, and this is called propanol or propane 1-AN. So functional group isomerism, two or more compound having the same molecular formula, but they differ in their functional group are called functional isomerism. Next, we will discuss metamers or metamerism. What do you mean by metamerism? In the metamerism, when two or more compounds having the same molecular formula, but they are differ in the distribution of alkyl group around the functional group, are called metamers, and its phenomenon it is called metamerism. For example, I will write CH3, O, CH2, CH2, and CH3. This is called ethyl methyl ether. Here functional group is ether is there. Alright, its isomer. I'll write here oxygen as the ether functional group, CH2, CH3. Here also I'll write CH2 and CH3. This is called diethyl ether. So what is metamerism? I said distribution of alkyl group around the functional group is different, are called metamerism or metamers. See here, in this case, this is the ether functional group. If you see the left hand side, so here you will find 3 alkyl group is there. Sorry, 1 propyl group is there, but 3 carbon atom you will find. Here only 1 is there. In this case, so what happened here? Here 3 carbon atom is there. Here 1 carbon atom is there. Here 1 propyl group is there. Here 1 methyl group is there. But in the second isomer, here you will find 2 alkyl group on the left hand side. Sorry, 1 alkyl group and it's 2 carbon atom, and right hand side you will find 2 carbon atom and 1 alkyl group. Means distribution of alkyl group around the functional group is different, are called metamers, and its phenomenon is called metamerism. So next we will discuss the another type of isomer, that is stereoisomerism. I said what is mean by stereoisomerism? In the stereoisomerism, when two or more compounds having the same molecular formula, but they are different in their space. Spatial arrangement of atom or group of atom is different are called stereoisomerism. So we'll study right now what do you mean by geometrical isomerism. In the geometrical isomerism also, when two or more compounds having the same molecular formula, but they differ in the arrangement of atom or group of atom around the carbon double bond, it's called geometrical isomerism. Okay, so let's discuss example right now. Example I will write C double bond C. Here I write COH. Here also I write COH, COOH, and here I write H. Here I write H. This is called malic acid. Its isomer I will write C double bond C. Here I will write the COH. I want to change the position of the COH. Here I write H, and here also I write H. This is called malic acid. This is called geometrical isomerism. See here, if I hold this is carbon-carbon double bond. If I look one side of the carbon-carbon double bond, here COH group is there, here also COH group is there. But in this case, COH group is attached opposite to that carbon-carbon double bond. So this is called geometrical isomerism. Okay, so this is the C double bond C is there. Around the carbon double bond, if it is only one side, the similar atom or similar group, if it is placed then they are called cis isomer. And same atom, if they are placed at opposite side of the carbon double bond, then they are called as a trans isomer. See in this case, this is the C double bond C is there. This is the carbon-carbon double bond is there. Here COH group is there. Here also COH group is there. Similar atom or group of atoms they are placed opposite side of the carbon double bond are called trans isomer. This is called cis isomer, and this is called trans isomer. Okay, so I will write one more general example. C double bond C is there. Similar atom or similar group I want to place same side of the carbon double bond. This is called cis isomer. And what is my trans isomer? Similar atom or similar group if they are placed at opposite side of the carbon double bond. I write C double bond C. Here I write A. Here I write A. Here I will place B. Here I will place B. This is called trans isomer. Similar atom or similar group and placed at opposite side of the carbon double bond. This is called trans isomer. The best example is malic acid, where two COH group is attached only one side of the carbon double bond, and in the fumaric acid COH group is attached opposite side of the carbon double bond are called trans isomerism. Next we will discuss optical isomerism. Optical isomerism, somehow it is related to the light. What do you mean by optical isomerism? When two or more compounds having the same molecular formula, but they are different in the direction of rotation of plane polarized light, are called optical isomer, and its phenomenon it is called optical isomerism. So let's discuss example. Example I will write COH, here I write C, CH3, here I write OH, and H I will write. Sorry, here I write the H, OH and CH3, and its isomer I will write C, OH, here I write H, here I write OH, here I write CH3. I have shown on the board two examples. One of the example is called plus lactic acid, and second example is called minus lactic acid. So these are the example of optical isomerism. What is the optical isomerism? When two or more compounds having the same molecular formula, but they are different in the direction of rotation of the plane polarized light. If the plane polarized light will pass through the solution, and if it is rotate clockwise direction, then we can call as a plus lactic acid. At the same time, if it is rotate anti-clockwise direction, they are called as a minus lactic acid. So this is called optical isomerism. So here I am going to stop. The remaining part I am going to discuss in the next class. Thank you.